Welcome to Almost Here, Round the Corner Future Technology podcast with Richard Jacobs. Future technologies poised to transform our lives for better or worse are the focus of this podcast. Almost here means these technologies are now here and starting to be used, or just around the corner, from Bitcoin to artificial intelligence, 3D printing, blockchain, virtual reality, and more. Hey, this is Richard Jacobs with Future Tech Podcast, Almost Here, Round the Corner Technology. And today I have Paul Snow at Factum. Paul, instead of me bungling it, would you tell people what Factum is and what it does?
Okay, well, we're a startup here in Austin, Texas. We've been live with the Factum protocol since September of 2015, and just got through doing one of our major updates and continuing to work on the protocol. Making it faster and better and easier to use. The idea of Factum is to provide a general purpose data layer secured by the Bitcoin blockchain, and we are building a platform that will eventually be distributed and autonomous across quite a number of parties. It will have users that are using the protocol driving the process of selecting who runs the protocol and moving it forward that way. So basically, people that use the protocol are the ones that are calling the shots to decide who runs the protocol. The ones that run the protocol get a certain amount of reward every month to incentivize them to want to run the protocol.
When you say reward, do they get factoids? Or
yeah. Factum has a token, and the token's existence serves two purposes. Primarily, it provides an incentive for people to run the Factum servers that are central to the protocol's existence, and secondarily to act as a anti-spam mechanism to prevent people from just throwing trash into the data layer. Because basically the data layer exists to create a level of data integrity, a mechanism to prove the data integrity of information that's being exchanged via various applications.
Okay, so if it was free, there's a potential for abuse, but it has probably some small cost.
Yes.
Which makes it less likely to be abused.
Exactly. Okay. There's a small cost, and so people don't want to spend their own money to spam. And this is a feature that was explored early on with a concept called hash cache with Adam Beck, and the idea was to do some sort of proof of work before you sent every email. And
that would be nice.
If every email package required a certain level of proof of work before we considered the email valid, then spam would be impossible, because spammers would have to invest in so much computing power that it would no longer be viable to spam people with emails. For whatever reason, it didn't catch on, and that's okay. But the puzzle, the proof of work that Adam Beck pioneered, was eventually picked up by Satoshi Nakamoto as his proof of work for Bitcoin.
Interesting.
And Bitcoin, as many of you are aware, requires a ever-increasing amount of proof of work as more and more computers are working on the problem of securing the Bitcoin blockchain. And right now there's just, huge amounts of computing power that's built to make these very, very, very difficult to compute hashes for these blocks of data, the ledger, the Bitcoin ledger. And it is certainly the most secure data structure that exists in the world. And yet, despite the massive amount of security that Bitcoin has, the ledger itself is only 1 megabyte every 10 minutes.
Right.
And for a lot of data applications, not moving value, but simply securing data and securing the provenance of data, basically think of it as a document with revisions. If I want to watch that document move through time, I not only need to hash each version of the document, but I have to group them in some way so that I can see what hashes existed in the past, and more importantly, really, what hashes didn't exist. In other words, to be able to prove the negative on the history of that document. And in computer science, anytime you hear a computer science guy say document, you can hear any digital thing. So it could be versions of a song as an artist goes through the creative process of developing music.
Okay.
And that would prove not only that he wrote the song, but it would document the creative process over time. A much stronger proof that that the artist was the originator of some piece of work. And
yeah, like for instance, you could document, let's say he revised a song 5 times, once a month he did a revision. You would document each revision with a timestamp, and you'd see the whole creative process essentially.
Exactly. And let's suppose the lady creating this music gets in a lawsuit later on. There have been a number of lawsuits where the only proof of plagiarism is that a song has a set of chords that are similar to another song.
Right.
But in reality, there's only so many chords, and there's certain chord progressions that exist in almost any music, and so it becomes a real difficult question whether someone took an existing song and slightly modified it for their purposes, or whether through the creative process they happened to land on a few chords that went in the same order and sounded similarly. So if you've got the documented creative process, I think you would have a stronger case. None of this is proved yet, but in court, but it makes a lot of sense that it could work that way.
Is this the answer to the reason behind Factum and what it does, or have we not gotten there yet?
Well, yes, and this is what Factum does. Factum provides this mechanism to group something. We call them into your own user chain. You can create a user chain for some business process, for some creative process, for managing some document, for managing some lightweight identity, and as you add to that chain, you end up with a group that you can iterate across and examine those entries. Each entry in a Factum chain is 1 to 10K in size,
okay.
And you can stack a bunch of them entries side by side to create bigger data structures.
Are you guys hoping that there is, no one hopes for a lawsuit or a court case, but are you hoping that your method...
A process by which the parties involved build a timeline.
Okay.
And that timeline for a lot of high-risk business processes could be pretty much eliminated if there was effectively an audit trail as parties are moving through a business process, nailing down what happened, who did it, when did it occur, and what effectively wasn't done by looking at elements that are not in that chain. So these lightweight, inexpensive audit trails could pretty much revolutionize a lot of the management of things that today are very difficult to manage.
So what do you think would be the best use cases for listeners and for you guys to get this proof of concept out there? Like, what do you ideally want to see happen first? What adopters do you want or have?
Well, we're working on document management in a number of industries, things like healthcare and mortgages and sensors for along the border for national security. Those are the projects that we have been talking about in the news. For instance, with DHS, they have devices that take pictures and take video, and if the device itself could create hashes and place them into a particular chain in Factum, then when DHS says these are the photographs this device took within this period of time, there would be cryptographic proof that A, these were the actual images they took, undoctored, and B, they're not withholding anything. And if they did need to withhold something, let's say there was for some national security reasons, they couldn't release certain images, those images could be submitted to a court for oversight and provably audited for the reasons that they can't be released. And thus you have a mechanism for holding an agency like DHS accountable, even if the information that's been requested isn't released. This is something that you really don't have today. We have a very difficult time with the government when they say they can't when they say they cannot release certain information. There isn't any proof of how much information they are not releasing, and there's no proof that the oversight actually sees all the data and can evaluate all the data. So this kind of mechanism can create ways of holding even very secret agencies accountable without having to release critical data, basically secret data, confidential data, top secret data, whatever, classified data. You wouldn't have to release that data because you can at least document the sort of data that might exist and prove that all that data was reviewed.
Is the Bitcoin blockchain pseudonymous enough that you think government agencies would allow their data to be documented there, or do you think they're going to want their own private blockchain?
Well, see, keep in mind that the way Factum works is Factum does not put data into the Bitcoin blockchain. The only thing that we're getting from the Bitcoin blockchain is the proof of work, basically the massive safe that is Bitcoin that prevents anyone from modifying data. If you modify anything that goes into the Bitcoin ledger, if you modify any of that, you break the hash and you break the proof of work. So I have cryptographic proof that the data hasn't been tampered with. The only thing that Factum puts into the Bitcoin blockchain is a hash.
So that hash may be comprised of 10 user chains that have been hashed 20 times all the way down, and I guess you call it like a Merkle tree.
Yes.
So the root of this one final hash, that's what's put into the Bitcoin blockchain.
That's right. And a hash, we like to use this illustration or this object lesson around here. Brian Deary came up with it. He had, I've got it right here in my hand, a can of corned beef hash. Okay, this could be considered proof of a cow. But if you have this can of hash, you cannot reproduce a cow. You can prove that a cow existed, and if you analyze the DNA, you could prove that it is actually a cow in here. But you could not get the cow from the can of hash. It has been completely crushed down and chopped up and cooked and stuff to the point that there isn't any possible way you can reproduce the cow from this, but you could prove that the cow existed.
Right.
And that's the nature of hashes. You take a large amount of data and you crush it down to 32 bytes. 32 bytes is just doesn't hold enough information to reproduce the data from whence it came.
Right.
Much like an address cannot tell you anything about the building that's at the address. If all you have is the address, you can't tell if you've got an office building, a residential building, a small shack, a mansion. It's just an address. Right. And that's the way hashes work. But unlike an address in a building, where there isn't really anything about a building that can't, you could build a different street. You could just go renumber a street. There's a lot of ways addresses and buildings might not be firmly connected. But a digital hash and a digital document of any kind is a one-to-one thing. If you change one bit in the document, you get a completely different hash.
Yeah, I guess, I don't know if it's a great analogy, but I liken the Bitcoin blockchain to like a gigantic Jenga tower. And if you pull out one block, the whole thing collapses.
Right, and that one block is one bit. One bit's different, it all collapses. And we build...
you have comma, right, or a space, or a letter, or one pixel in a picture.
Right. I mean, it could be a change that's so small that a human could never find it looking at it. I mean, you can use tools to find it, but, I mean, can you really tell if your red shirt is 1/1000% different in hue?
No.
On one thread? You couldn't see that. But you change effectively one thread in your shirt, if your shirt's a digital document, and you will get a completely different hash and it won't match. So this is proof that not just the document hasn't been altered, but it literally has not been altered in any way, or the hashes break. Okay. And so I don't believe that governments will have any problem with using Bitcoin as the proof of work that exists in Bitcoin to secure the data integrity of data.
Well, I do have one question. So you talked about addresses. So I can tell, based on an address, if it's on a main street, somewhat. I can tell certain things about the property. Perhaps the same as with Bitcoin blockchain. I'm sure there are a few things where you can kind of tell, okay, I can tell some things about this address, but not nearly everything.
Like Fifth Avenue.
Yeah.
If your New York Fifth Avenue address,
right,
that tells you something. If I say Main Street, Medford, Oklahoma, that tells you something else.
Yeah.
Digital hashes, no.
Nothing like that.
No.
Okay, good.
Digital hashes are like lottery numbers. There is a one-to-one correspondence between a document and a hash, but you change anything about the document, you get a completely, radically different 32 bytes. It's like rolling dice for 100 years again. Wow. It's actually worse than that. The complexity of a 32-byte number is, most laymen think that if I say 32 bytes, which for all practical purposes is 32 characters, many of us couldn't write our address in 32 characters, just not long enough if it were a form. But if I look at it mathematically, where each character is one of 256 options, and I multiply 256 times 256 times 256, so forth, for 32 times, I get a number so astronomically large that when you're taking a document and you're just randomly picking a number within that space, and it's just crazy different.
Right. Okay.
No relation whatsoever, one hash to another. Tells you nothing.
So what? So you talked about Department of Homeland Security, mortgages. I forget what else, but any other?
We have a contract with or a project, a grant from the Gates Foundation.
Okay.
And what we're doing there is we are working to create a way to find and locate medical documents for people in the developing world, like, for example, let's say a country in Africa, or one of any other areas, might have civil wars, might be having regime changes on occasion, could be that very, very few resources, and so that NGOs, non-government agencies, organizations, are swapping out Maybe one group provides some medical care for a while, and then that group leaves, and another group comes in. So you might have a combination of charities, of clinics, of government organizations, and others coming in and doing providing care for the population. Now now you have a person who comes in for treatment. It becomes very critical to have their medical history, an accurate medical history, and a immutable ledger, perhaps tied to a biometric marker of some kind, could provide a means of gathering this information from many different organizations and ensuring that you have the medical documents to provide the proper care. What does that do? It means that you don't duplicate vaccines, if the person's up to date. It means that you don't provide treatments that are in conflict with treatments in the past. Perhaps it means that you have better tools for diagnosis because you can get notes from other visits with other care providers. So in an environment where things are somewhat chaotic and look, face it, even in the United States, when you go in to see a doctor, after you've moved through 5 or 6 towns or something like that and gone through several insurance companies and found different doctors that were covered by your different insurance plans over time, you may have a very hard time providing a coherent medical history to a physician.
Well, the thing is, too, you're relying on the doctor or the hospital or these institutions to keep your data, and it really should be yours that you take with you. The doctor may go to a different hospital, may shut down, may die, so your information is really in the hands of other people. Maybe this would put it within your...
Well, it can conceivably. Now, America and the Western Europe and places like that, we have first world kinds of problems. We want control of our information. Privacy is a big concern, and that sort of thing. In the developing world, it may be a little pumped over, and it may be that there's more concern about how do I get the information to the provider who's providing care, with kind of secondary concerns about ensuring that there's the proper privacy and proper protections of that information. Okay. Because the extent that you need to go to protect private information is kind of dependent upon how valuable that private information is. For example, I have a number sitting on my desk, right there. I just looked on a piece of paper and it has a number. It's private. You don't know what it is, but I'll tell it to you. It's 3. Okay? Well, 3 doesn't tell you a lot. It's not very interesting. And even if I were to tell you that's the page number that I pointed to, okay, how many documents have page 3? Right. And how many documents do I have to have page 3? Now, if that turns out to be some critical document that has my secret keys to tons of Bitcoin or something like that, now those are numbers I really, really, really wouldn't tell you. Right. Okay. But so basically, things that really, really need to be private need to be protected quite a bit. Now, our health information in the U.S. on a person-by-person basis has a great deal more monetary value and can be more easily abused in the Western world than in developing countries. And hence there's a difference in security concerns. But, I mean, it's all a concern. It's just a question of what's more important. We're trying to prevent the loss of life and the delivery of better care in a world where that's difficult to deliver. In this particular case with the Gates Foundation, we will learn quite a bit that we can apply to the Western world, and we look forward to doing that.
Okay. So where is Factum today? We're doing this interview in early 2017. What's the plan for this year? how much adoption is there going to be of it?
Oh, well, massive adoption worldwide, disruption, many industries changed. It's very, very hard to tell. Some of that is a little facetious. Some of it is some hope. We do believe that by this time next year, there will be big changes in at least some sectors, in some small corner of those sectors where we are able to deploy this technology and show how it reduces cost and reduces fraud, waste, and abuse, and provides more accountability, makes things work better, and we look forward to proving that. Technically, on the protocol side, right now we have the distributed protocol running, and it's live, and we intend to, over this year, move towards elections, and elections will firmly distribute the operation of the protocol across many parties and provide the users of the protocol a voice in ensuring that, in governance, ensuring that the people that are running those servers are the best people for the job and provide oversight.
So when you say running a server, is that like running a full node?
No, this is more like running a miner, except Factom doesn't really have miners. And so what we have are federated servers. And the federated servers are elected effectively by the users of the protocol. So Factom is an exercise in setting up all the incentives and governance and oversight of a protocol and distributing the responsibility across many parties. And the idea is that if you have distributed responsibility and distributed oversight and distributed elections feedback that's weighed by your interest in the protocol, not weighed by speculation, that you can build a distributed autonomous protocol that runs without a centralized authority that's running the show. So that's the idea.
So how does where does the weight of a given vote come from?
Comes from the entry credits. Factom is the only cryptocurrency out there that I'm aware of that has a two-token system. We have the tradable token that provides our incentives, the factoid, and it's listed on exchanges. You can buy it, and that sort of thing, from exchanges. It varies in price. On the other side, we have entry credits. Entry credits are actually used to drive the protocol. The exchange rate between the factoids and the entry credits is dynamic, set by the server, the people running the servers. It is intended to be kept stable. Right now, the target is 1/10 of a cent per entry credit. An entry credit buys you 1K of data in a chain somewhere. And if you wanted to create a chain, you use 10 entry credits, or about a penny to create a chain, and 1/10 of a penny to put in a small entry. A bigger entry, like 10K entry, would be a penny. Basically 1/10 of a cent per K. The entry credits, this two-token system provides a couple of things for us. One, it allows the users of the protocol to avoid ever buying a tradable token, because if I'm a bank or I'm a government or I'm a business, I don't want applications to have to be managing wallets and tradable tokens, which increases risk of hacking, because basically tradable tokens are worth money. And if you have to put money into the applications that you're running, then you increase the risk of some hacker trying to break into the application to steal those tokens. Furthermore, there's regulatory issues with trading tokens, and there are also issues where accounting becomes difficult, because what if you buy a set of tokens and they go up in value astronomically? If I'm buying tokens to drive an application and they can go up dramatically in price, then suddenly I've got tax reporting issues. And who wants a document management system that's providing the prepper data integrity and everything else to have to be tied into your accounting system for tax purposes?
Yeah, it makes sense.
Yeah. So the entry credits, because they're fixed value and they're non-tradable, they act like coupons or a subscription. You have a fixed cost up front, you use them up, and you buy some more. They're like gas that you put in a car. Mm-hmm. It's an expense you account for occasionally, and then you just don't worry about it otherwise. And the other thing is that because we have the two-token system, there's one token transaction to purchase some number of entry credits, and then those entry credits just decrement down as you use them. Right. It turns out from a data point of view, that's a much smaller transaction to document a decrement of a register, because there's no input and output. There's just the one thing that gets decremented. Okay. There's a lot less bookkeeping, so it reduces how much data that's in our system. The other thing is we segregate the entry credits away from the actual data. So if you've been following Bitcoin and listening to their segregated witness and all that sort of thing, this is a mechanism that's like segregated witness on steroids, because in the end the data is completely separate from these entry credits that we're decrementing, and which are completely segregated away from the factory transaction that created the entry credits in the first place. Okay. So all of this is a mechanism to reduce how much data an application has to look at to run, because in the end the application doesn't care about all the bookkeeping that we need in the protocol. Right. They only care about the data.
So what's the stake required to have a voice in choosing the federated servers or have a voice in Factom's future?
You buy the entry credits, you get a voice. And so the vote that you make towards your servers will be based on a signature of an entry credit address, and the weight of that will depend upon the entry credits that have been added to that address, and when they were added. So having spent entry credits in the past doesn't necessarily mean you have a voice forever. It means that you have a voice for a while. And the particulars of how this architecture will work, we're going to be working out over the next year. There's some other discussions about it that I've written up and put out there in our white papers for Factom that can be found in GitHub in the Factom docs repository, or going to our website. You can find the documentation, factom.org and factom.com.
Okay, just a couple of quick final questions. Any showstoppers or potential big problems you see coming that would affect Factom, causing it to have to anchor into a different blockchain, or anything that would really shake up the whole ecosystem and affect you guys?
Well, it won't affect us much, but what we intend to do right now, and we haven't yet, but in the next couple of months, we'll begin anchoring in Ethereum, and we'll also be anchoring inside of Bitcoin, of course. And those anchors will be available for other parties to record and keep as their public witness of these Merkle roots for the Factom ledger. If I have one Merkle root of the latest block, there's basically a hash chain that goes all the way back to the Genesis block. In fact, I can basically prove everything from that hash all the way back. And if I want to prove the timestamps, the time in which blocks have been written, within some fairly large margin of error, certainly, but certainly not, days and weeks, right? Then when you go through the Factom ledger, you find you get these anchors, these hashes that are documented, and I can find the Bitcoin transaction where those hashes exist. and I can basically peg to the Bitcoin blockchain the ledger that was created in Factom. You could kind of think of it as a bridge that has pylons that go down.
Okay.
Basically, Factom is providing a way to take this proof of work that Bitcoin is creating, which is a massively useful and massive in security resource that right now can only be applied to pretty much a megabyte worth of data per 10 minutes.
Right.
Factom is increasing that by orders of magnitude. There are some 10-minute blocks in Factom that are 20, 30 megabytes in size. Well, I can't put 20 or 30 megabytes of data into a 1 meg block.
Right.
And in fact, I probably can only put I'd be lucky to put a K into a block reliably. So Factom provides a way to get that security, the hash power of each of those Bitcoin blocks, and apply it to much bigger data sets.
Yes. Okay. Any factors you see on the horizon? Maybe I guess you went to Satoshi Roundtable.
Yeah.
Be able to disclose anything you got from there that you can disclose, or anything you know that could be potential seismic changes in the industry?
Well, there are a lot of things that were said that were very, very interesting. One is that there were people talking about discussions that are being had at the highest level in a lot of banks. One of the comments is that there's an extinction event on the horizon. And just the same way cars, eradicated certain businesses like the buggy whip business and the horse carriage business. Okay, wasn't immediate, and it was over time, but it was pretty substantial and pretty quick. Airplanes and automobiles eradicated the passenger train for much of the country. We still have some commuting trains on the East Coast and some other places, but compared to the predominance of a mode of transportation that the train was in the 1800s and the 1900s, it doesn't exist today.
Right.
It's pretty much on the sidelines. Not that trains aren't moving lots of freight, but passenger trains change. So there are these big events, and the blockchain and instant settlement and data security, breaking up systems of record into systems of authority, where there's an authority that assigns credibility to certain data, but there are many systems that can hold it and use that authority. These are going to radically change a lot of businesses, and banking is one of the businesses that are apparently, according to people at Satoshi Square or Satoshi Roundtable, a lot of these people are saying this is an extinction event, that blockchain is radically going to change banking and finance. We have had banking and finance move from 3% of the GDP in the 1800s to today, if I restrict it to just the services that banks provided in the 1800s, banks are arguably 8%, 10% of GDP today. If I add the services that they've invented since then, banking and finance could be as much as 30% of GDP. Well, 30% of GDP is 10 times more than 3%, for those of you that are not math savvy. But that means that they've been outstripping production production of goods and services, the hardcore stuff that we used to build.
Yeah.
I believe that the blockchain could significantly increase of efficiencies, and I believe Bitcoin as a store of value could significantly change how finance works, maybe even change how monetary systems are viewed. And I believe that big changes are on the horizon, and they're across the board from the concept of value and how you define value and how you maintain value over time, stores of value, distribution of value, those sort of things. And that's going to change things. Data integrity is going to change things. Audit trails are going to change things. And, yeah, it's going to be amazing.
Okay. Anything else I should have asked you? I mean, there's a lot to talk about. You've got a huge store of knowledge. You got a gigantic Merkle tree of knowledge in your head. But
Yeah.
Any last thoughts that we should talk about, or is that good?
I think that's pretty good. Some people ask me if I'm worried about Bitcoin. I think Bitcoin is proving to be way more resilient and useful than anyone ever expected. I believe that we have demonstrated that Bitcoin can move from a payment rail for a few weirdo libertarians, right? And move towards a store of value that could conceivably be used by institutions and for investment. We will have a cryptocurrency payment rail. The question is whether it will be based on Bitcoin or other tokens. So I predict that 2017 will be a even greater year of change for the cryptocurrency world, and I'm very optimistic. I'm very excited. I'm giving no particular predictions because my predictions tend to be completely off base.
Right.
But that's pretty much my view of the sphere, and so for as much as anybody cares about my views.
Yeah, well, very good. All right, Paul Snow of Factum, thanks for taking the time. I appreciate it.
Yeah, no problem. Thank you.
You have been listening to Almost Here, Around the Corner Future Technology podcast with Richard Jacobs. Subscribe to this podcast, post a review to discover more future technologies that are poised to transform our lives for better or worse, such as Bitcoin, artificial intelligence, 3D printing, blockchain, virtual reality, and more.
We have had banking and finance move from 3% of the GDP in the 1800s to today, if I restrict it to just the services that banks provided in the 1800s. Banks are arguably 8%, 10% of GDP today. If I add the services that they've invented since then, banking and finance could be as much as 30% of GDP. Well, 30% of GDP is 10 times more than 3%, for those of you that are not math savvy. But that means that they've been outstripping production of goods and services, the hardcore stuff that we used to build.
Yeah.
And I believe that the blockchain could significantly increase efficiencies, and I believe Bitcoin as a store of value could significantly change how finance works, maybe even change how monetary systems are viewed. And I believe that big changes are on the horizon, and they're across the board from the concept of value and how you define value and how you maintain value over time, stores of value, distribution of value, those sort of things. And that's going to change things. Data integrity is going to change things. Audit trails are going to change things. And, yeah, it's going to be amazing.
Okay. Anything else I should have asked you? I mean, there's a lot to talk about. You've got a huge store of knowledge. You got a gigantic miracle tree of knowledge in your head. But,
yeah.
Any last thoughts that we should talk about, or is that good?
I think that's pretty good. Some people ask me if I'm worried about Bitcoin. I think Bitcoin is proving to be way, way, way more resilient and useful than anyone ever expected. I believe that we have demonstrated that Bitcoin can move from a payment rail for a few weirdo libertarians, right? And move towards a store of value that could conceivably be used by institutions and for investment. We will have a cryptocurrency payment rail. The question is whether it will be based on Bitcoin or other tokens. So I predict that 2017 will be a even greater year of change for the cryptocurrency world, and I'm very, very optimistic. I'm very, very excited. I'm giving no particular predictions because my predictions tend to be completely off base.
Right.
But that's pretty much my view of the sphere, and so for as much as anybody cares about my views.
Yeah, well, very good. All right, Paul Snow of Factum. Thanks for taking the time. I appreciate it.
Yeah, no problem. Thank you.
You have been listening to Almost Here, Around the Corner Future Technology podcast with Richard Jacobs. Subscribe to this podcast, both to review, to discover more future technologies that are poised to transform our lives for better or worse, such as Bitcoin, artificial intelligence, 3D printing, blockchain, virtual reality, and more. Future Technology podcast with Richard Jacobs. Subscribe to this podcast, both to review, to discover more future technologies that are poised to transform our lives for better or worse, such as Bitcoin, artificial intelligence, 3D printing, blockchain, virtual reality, and more.